In 2018 alone, U.S. construction companies spent more than $177 billion in labor costs due to design and construction rework. Through their research, this team identified common design defects, their causes, and impacts of design errors. This presentation defines leading indicators to help ensure the completeness and correctness of design deliverables for building projects. Here to share their knowledge, please welcome Corr, James O'Connor, Mauricio Rodriguez, and Nancy Wilkie.
I'm Nancy Wilkie from the U.S. Department of State's Overseas Buildings Operations, and this is RT320 team members. I personally want to thank each and every one of them for their contributions to this effort, and I know that they all welcome you here today as well. So, design defects have been a long-standing challenge. They are too common, too costly, and face it, they happen we find out about them way too late. So in one study of 139 projects, the average cost of design errors was 14.2% of construction costs. Another study showed of construction personnel, they revealed that 27% of delays was caused by defective design. And finally, another sampling of 7 projects showed that 26% of rework was caused by design-related issues. Now, these are big numbers. And guess what? Our own study showed that the impacts from the design defects that we identified are attributed to many things. But among the greatest are those shown on the screen, which are construction impacts, cost increase, schedule delay, and operational impacts. And we'll touch on this slide in a few minutes. So, what if you could prevent design errors from occurring at all? Or, what if you could anticipate problems and mitigate them early? Sounds pretty good. And what if you could avoid cost overruns and delays? Well, that's what we want to talk to you about this afternoon. So going back a little bit, in 2014, to address engineering and design defects, RT320 was formed to improve design quality for the industrial sector. And in 2016, those findings were presented to the CII conference in Maryland. That team developed a tool called the Design Deliverable Quality Assessment Tool, and that tool actually is still on the CII website and available for your use. So, why did we develop another team? Well, the Department of State's Overseas Buildings Operation saw the potential in the methodology of this research, but wanted to expand that to focus on buildings. So, RT320A was formed from CII's facility and healthcare sector. Now, those of you in other sectors, you can stay awake because you might recognize some of these facilities. And let's be real. Almost every single sector of CII, they design and construct buildings too. They can be offices, warehouses, or other kinds of support facilities. So this should be relevant to almost all of you. So with the shift of focus, we needed to understand the differences between the industrial and building sectors. And we knew that the design quality issues were complex. And so we started by understanding the project phases and the timing of the detailed design when we would be doing our research. We also needed to understand the number of deliverable types that we would be looking at, as well as the number of technical disciplines that were involved. Our team also spent a great deal of time discussing design deliverable quality. The earlier team, RT320, defined quality as complete, timely, and correct. RT320A wanted to break down the issue of correctness further and its impact. So through literature review, we developed 11 drivers of design deliverable quality. You can see that on the slide in front of you, but that includes issues such as constructability, operability, maintainability, and meets project requirements are those business or agency-specific goals such as sustainability goals and or program. But the main takeaway was that understanding these drivers helped us to understand defects and why they happen. So with all that to consider, we had a tiger by the tail. So we gathered our chair and our whips, and we set out to tame the beast. And so Jim O'Connor from UT Austin is going to tell you how we got started.
Thank you, Nancy. Let's talk about our research process. But before I do that, the entire team would like to recognize and thank the Overseas Building Office of the United States Department of State for funding this study. Thank you very much.
You're welcome.
We chose to take a bottom-up approach to understanding design quality for buildings. By that, I mean we started by identifying problematic deliverables, and then we identified problematic defects with the deliverables. So in that sense, the whole study is based on a bit of a Pareto sort of analysis or principle. So how did we go about that? Of course, a survey. What else, right? So we presented 84 common building-related design deliverables, a collection of 51 industry experts. These are design managers, project managers, construction managers, people with well-rounded perspectives. And they collectively identified the 7 most problematic deliverables. So let's check those out. The specific trouble spots are roofing details, mechanical controls, exterior wall systems, low voltage systems, installed specialty equipment, project phasing, which is particularly relevant for renovations and expansions, and delegated design, which usually involves a third-party designer and certainly complicates life. So examining these 7, stepping back, looking for trends, we see deliverables that are associated with technical complexity. We see some deliverables associated with organizational complexity. We see a few that are associated with both. We'll come back to these shortly. Okay, our next step was about taking those deliverables and identifying problematic defects. So we started by collecting or identifying and involving 66 different subject matter experts across the 7 deliverables. And they collectively identified 126 defects. That's way too many. We had to narrow the field, shorten the list, somehow, some way. So we did that firstly by merging and combining similar or like defects. We then screened defects based on relative frequency of occurrence and relative magnitude of impact. And together we were able to screen that down from 126 to 47. And that 47 then amounts to about 4 to 9 defects per deliverable. Given the amount of time we had, given our resources, that was a reasonable task for us to accomplish. Next came an in-depth analysis of causal factors and impacts. So we went back to those subject matter experts, had phone interviews, and surfaced causal factors that often lead to defects, impacts which often result from defects, and sort of stepping back, we could see, well, causal factors can pretty readily lead us to an understanding of leading indicators, and leading indicators. If we are forewarned of those things, we can go after prevention. And that's what the whole study is really about at the end of the game, is prevention. In fact, I was thinking about Art Markman's comments, and to use his terms, the bridgeable gap that we sought to close was that link between defects and prevention. Of course, impacts are interesting and informative because they serve as a motive, a case for action, if you will. So let's sort of revisit that. You saw this a minute ago with Nancy. Just to reiterate, construction impacts are occurring on 3 out of 4 of these defects, and these can be quite painful. You all know this all too well, but examples would include rework, delays, coordination problems, productivity losses, RFIs, change orders. I know you guys love all those things. It certainly is a motive, I think, for taking action. So let's set those aside. Let's examine deliverables and defects in a little more detail. And up next is Carol Corr with Kaiser Permanente. She will discuss design defects with exterior wall systems.
Thanks, Jim. Hi, everybody. It's great to be here today. I'm really excited about being able to talk to you all about this. What I'd like to do is talk about some of the defects and impacts, as well as some of the prevention methods related to the exterior wall system, which is one of the 7 deliverables that we found is problematic. So one defect of note that shows up on the tool is that the exterior wall details are overly complex, potentially introducing future performance problems. So notice that cherry picker with the 2 arrows there? That actually was stationed there permanently in front of the building to fix leaks. So just think about how much money is being spent to fix the ongoing leaks because of to keep the cherry picker there.
Carol, just one question. How many people budget for a 24/7 cherry picker during facility operations?
No one does, and no one should. But because of that, now the owner has a big headache. They have to continue to maintain the building, and some of the impacts that they found because of this are things like water leaks. They had change orders even during design and construction, corrosion of the facade, as far as they had problems with decreased durability, and also problems with energy efficiency. So here's another example. Have you ever walked by a building and noticed overnight it seemed to be draped in plastic? Well, there are a lot of causal factors to that, and some of them are things like the system is too complex. Sometimes there's a lack of consideration of the interface between materials, as well as a lack of understanding by the design teams on what they need to do. And also, sometimes there's a lack of responsibility for the final product. So what happens is the occupants may see this. You may see things like leaks in the ceiling. You may have problems with mold. You may see windows that leak. You also might see walls that leak, again, mold and just water everywhere on the floor. And worst case scenario, you may have a whole system that comes down on you like your roof.
Good grief, Carol. Now the building's a threat to occupant safety and health.
It sure is. So what do we do about that? So actually, before we even go there, I have one more example for you. This is a building from 1974 in Boston. So imagine, you're in Boston, walking down the street, minding your own business on a beautiful sunny day, and out of nowhere, a sheet of glass that's the size of your grandmother's dining room table just comes down and crashes down nearby. So the problem with this was that the window design was too stiff, the windows could not expand or vibrate, and the panels started cracking at the building connections. Now, at 45-mile-per-hour winds, and what do you get? You get 10,344 panels of glass that fell. That's over an acre of glass, and this building ended up having plywood placed until the glass got replaced. The original manufacturer of the windows actually had to pay for that and replace it.
That plywood palace sure could have used our tool in 1974.
You know, that's an excellent point, Jim, and I agree with you. If they had our tool, they would have been able to anticipate some of these problems and actually be able to design the building and predict the problems and design it so that it was better in the future. So we want to prevent these issues, and we really believe that this tool can do that. When we talked to the subject matter experts, we did the work to develop the tool. For this specific problematic deliverable, we had a series of questions that we developed. Here's some examples. Did you have a specialty supplier or contractor that provided constructability input into the design, whether it was early on in validation, schematic design, or even into construction documents? Did you have a design that included familiar techniques, or did your unfamiliar techniques, they get thoroughly vetted by your subject matter experts? Another question that we developed, multidisciplinary collaboration. Was there an effort to make sure that there was a detailed design review of the exterior wall system? That should include subject matter experts, major fabricators, and suppliers. And also, we came up with what I think is most important. Was there a full-scale mock-up? And did that mock-up undergo specified testing? Really believe that if the tool was available, the projects that you just saw would have been better and had less of these problems. So now I'm going to hand it over to Mauricio Rodriguez, who's with the Smithsonian Institution. He's going to talk about mechanical controls.
Thank you, Carol. Exciting mechanical controls, right? Hi, everybody. So did you ever feel like the fellow on the block or the person on the block? Especially when it comes to understanding mechanical control diagrams and sequence of operations? Did you know that 1/4 of the leading indicator questions in our research pertaining to mechanical controls are influenced by commissioning? Any more questions? Well, the reality is that the design deliverables lack clarity when it comes to commissioning. This leads to poor planning of commissioning during construction, misaligned timing of testing and balancing with functional performance testing, and incomplete validation of the systems. In addition, operations and maintenance personnel do not often participate in the training and handover of the systems. What this leads to is to day 2 projects, which with the failure of the mechanical controls, meet the design intent.
Mauricio, it sounds like even though owner and operation manuals have been an industry standard for decades, we still haven't mastered this.
Yes, unfortunately, because of the lack of participation of operations and maintenance personnel, we still need a lot of room to grow in that area. So, aligning commissioning with design reviews and quality control and quality assurance, we can prevent impacts such as safety, delays in startup, and systems operating not according to design. Okay, now, in our research, our reviews and discussions with our team, we found that causal factors are as follows. There's a lack of knowledge about commissioning all around, especially in the details of planning during construction. There's ineffective design reviews, often failing to address the operations. The late involvement of operations and maintenance personnel and subcontractors and vendors leads to lack of collaboration during construction. Lack of commissioning fails to uncover latent defects in our systems. The influence diagram here on the slide shows the importance of starting commissioning early. On our own research team, 312 best practices for commissioning and startup, we recommend that the commissioning process begins early as projected in planning. And now I'm going to hand over to Nancy, who is going to address delegated design.
Thank you, Mauricio. Now, delegated design occurs when the detailed design and fabrication of one or more components is done by specialty contractors during the construction period. With the emergence of more complex designs, the lack of integration of multiple delegated design components we found to be a significant issue. In this example in front of you, there was a very clear design for the ultra-high performance concrete exterior fins, the steel support for the facade, and anchors supporting the fins back to the structure. But during construction, when detailed design went into the sub shop drawing phase, they were misaligned. What was the impact of this? It was huge. It was a huge time impact, rework impact, and massive coordination between the contractor, the subcontractors, the A&E of record, as well as the building owner. And it was not in the contractor's bid. The result, unfortunately, was millions of dollars of change orders and months of delay. In this case, the cause was that the specifications did not require the contractor as the responsible party to ensure the integrations of the delegated systems and their subcontractors together.
Nancy, excuse me. How could using our tool help anticipate and prevent this?
Very good question. One of the things our tool does is early on, it asks some leading indicator questions that help to prompt best practices. For example, the one that's highlighted in yellow asks about whether the team has developed a responsibility matrix identifying each delegated design component, interdependent systems, and their associated responsible parties.
So Nancy, is it critical design reviews ensures the design intent?
It absolutely does. And later on, we actually ask more specific questions, such as if the specifications for the delegated design components have been cross-checked for coordination, as well as sample and or markup efforts are complete and accurately specified.
So our tool would definitely prevent this, right?
It certainly should help by asking those critical questions early. So if we go back to our team effort, I'm going to introduce you to my neighbor Quigley, the camel, and this is Mei Jing from the National Zoo. And believe it or not, they worry about design quality too. They really do. And they heard him talk about the 47 defects that we focused on, our deliverables. At that point, we knew we needed to drill into the leading indicators and develop the questions that would lead us and drive us to defect prevention. With that, we also knew we wanted to emulate the tool that was developed by the earlier team. We wanted to extend that scope to facilitate risk management discussions by the project management team. So in all, our team developed 160 leading indicator questions that are prompted by the causal factors of our defects. And our team developed the design quality leading indicator tool. This tool, we think, prompts proactive prevention of design defects and effective risk management. So now Jim is going to elaborate briefly on the tool.
Thank you, Nancy. As Nancy said, our Excel-based tool is intended to help teams identify potential design defects in advance and to prompt the design team into preventative action. To accomplish this, the tool requires some inputs and it provides some outputs. Let's start with the inputs. Step number one is about setting the context for the analysis. And specifically, that would include picking one of the deliverables and picking one of 4 different design milestones. Step number two is about assessing the leading indicator questions for that particular context. And those numbers can vary between 8 and 25 questions depending on deliverable and depending on time frame. Move on to the outputs. Step number 3 generates a design quality index. This is a 100-point index score that is a reflection of the amount of risk you face in your design quality risk. Number 4 explains a little more detail as to how that came about. It basically reports on all those leading indicator questions to which you answered no. It also provides the associated defect just to shake you up a little bit. And then step number 5 is a little bit of input, a little bit of output. It is a prompt for team discussion and for documentation of a path forward to address the risks and the leading indicator issues specifically. Here's an elaboration on those 4 different milestones. So V stands for validation of schematic design. It actually happens at the kickoff of design development. DD happens at the end of design development. CD1 is midway through construction documents, and CD2 is at the end of construction documents. In general, when it comes to risk management like this, earlier is better from a proactive perspective, but an iterative approach is really the best approach. So we recommend an early approach and plan on repeating the analysis. Let's look at a couple of screenshots. Here's leading indicator questions. In this case, it's for delegated design. There are 8 questions. This is at the end of construction documents, and there's a bunch of fields. The tool leaves quite a nice paper trail, and we've been calling them yes/no questions, but you actually have a not applicable option as well, which removes it from consideration. Here's the risk management plan tab, and you can see leading indicator questions, you can see potential defects, and then you see the space within which you can record that path forward plan. Now, thinking back to Art Markman again, this is what he would refer to as the implementation intention to disrupt bad habits. You remember that from yesterday, right? And you can also, that last option was to assign a relative priority to the particular path forward. Okay, regarding the users, the tool is intended, as you would guess, for design teams, for design managers, and for quality managers. But given the breadth of deliverables addressed, a wide variety of project participants really could benefit from and participate in that process. Our final step was to have a validation review going back to our original subject matter experts. We had 9 reviewers provide 30 comments. Nearly half of those were compliments, as seen here. And based on that kind of feedback, we're pretty confident of the tool's contributions to design quality and to ultimate project success. So to conclude, if you care about buildings and if you care about design quality, this tool is for you. You can even access it, of course, off the ubiquitous app. So the question is, when? When will you all start pushing design quality through more preventive and proactive risk management efforts? With that, we are done. We have a couple minutes for some questions.
All right.
Thank you very much.
Thank you, Jim, and everyone for your presentation. You guys did a wonderful Q&A as you went, so that definitely helped. But there's some additional questions, so thanks everyone for that. Seems like quality is the issue. Are we not doing the basic tasks to define quality? Why is this tool needed if we follow best practices?
I think that quality has been something that we've struggled with for a long time. The absence of addressing issues when they're happening during detailed design wasn't in any of the great tools that we've had in the past. PDRI, all these other tools are looking at project planning, but when you're getting into the detailed design, you have to, by looking at those most problematic deliverables and those issues that give you the most impact, you're trying to get ahead of that and being able to prevent them from happening and understanding those risks involved in those components.
Okay.
So
I would also say that quality is similar to safety in its complexity, and that you can drop the ball in 1,000 ways.
That's true.
That's a good answer. Thank you. Is it only for buildings? What about industrial?
No, actually, what I think was interesting about the two, while we found very different deliverables that most impacted the industrial sector versus the building sector, they could be used by any sector. They're similar tools in the way they operate. We had issues such as constructability and maintainability in the industrial sector tool, and I know that there are plenty of issues that we're dealing with in the building sector that can be used by the industrial sector.
All right. So last question is, it says, this tool looks impressive. Many times project teams resist this type of engagement or involvement. Did you experience any resistance?
Well, I think we're still trying to engage the industry in using this. And so I'm hoping that people will start taking the tool, especially those who have issues in that problematic deliverable, and start using it. And as a building owner that I represent, if we find that it's helpful, we can also ask our A&Es to use that tool as they're doing their own quality assurance reviews.
Get a requirement.
And
Exactly.
our feedback from those reviewers was either a compliment or a suggestion on tweaking some timing. So we made some timing adjustments, but nobody disagreed with leading indicator questions or defects.
And we'd love some more volunteers, so we'll be at the showroom area after this. So anybody who's interested, come on over.
Let's go closing. Thank you so much for your presentation.